An abrupt and strong release of energy occurs when a radioactive substance atom divides into lighter atoms. The atomic bomb, which was only used twice in combat, both times by the United States against Japan, is an extremely potent weapon that derives its explosive energy from nuclear energy. The covert U.S. government research and engineering initiative known as the Manhattan Initiative produced the first nuclear weapons in history during World War II. In response to a letter from Albert Einstein alerting U.S. President Franklin D. Roosevelt to the possibility that Germany was working on producing an atomic weapon, this was done. The genius suggested that the United States follow suit in order to avert disaster. Under the direction of theoretical physicist J. Robert Oppenheimer, a large portion of the work was completed in Los Alamos, New Mexico. Private companies contributed to the development of the atomic bomb. DuPont contributed to the preparation of weapons-grade uranium and other necessary materials for the bombs. Reactors in Oak Ridge, Tennessee, and Hanford, Washington, handled the materials. The atomic physicists chose the isotopes plutonium-239 and uranium-235 to initiate fission. Atoms split during this process, producing neutrons that impact neighboring nuclei, causing further fission and the release of energy with each split. An atomic explosion is the result of what is referred to as a chain reaction. In contrast to the ubiquitous U-238, only around 0.7% of natural uranium is composed of U-235. Extracting U-235 was the scientists' first objective in order to create the atomic weapon. P-239, like U-235, required cautious extraction in order to produce fission during the detonation of the atomic bomb. Japan remained on the eastern half of the globe following the defeat of Germany and Italy by the Allies in May 1945, following 6 years of warfare in Europe. The atomic weapon was finished and tested in the wee hours of the morning at a military test facility in Alamogordo, New Mexico, 2 months later. A massive mushroom cloud and strong acoustic waves from the explosion broke windows in homes up to 50 miles away from the testing site. The Japanese War lasted until August 1945. The United States responded by formulating strategies aimed at compelling the Japanese military to submit. One of the possibilities was to set off the atomic bombs. President Harry Truman approved the deployment of the bombs after Japan refused to submit despite the threat of prompt and utter destruction, despite warnings of the imminent mass slaughter should they detonate. During the 4 months that followed the detonation, 210,000 civilians lost their lives as a result of the atomic bomb. Massive quantities of thermal energy, or heat, were emitted as the atomic bombs detonated, causing the bursting bomb to reach temperatures of several million degrees. Due to the massive fireball this thermal energy produced, earth fires broke out, destroying Hiroshima and Nagasaki at ground zero. A powerful shock wave was quickly created by the explosion, and it extended many kilometers from the blow before progressively decreasing strength. A few kilometers away from the explosion site, the wave demolished structures. Massive amounts of gamma and neutron radiation were also released. At a distance of 1 to 2 miles from the event, this deadly radiation quickly diminished. The fireball formed by the explosion's convection currents gathered dust and other elements, giving rise to the mushroom-shaped cloud that is typical of an atomic explosion. Among survivors, the long-term consequences of radiation exposure also led to an increase in cancer rates from 10 to 44%. It cut the lives of the survivors and their offspring short by 1.3 years. Don't forget to subscribe to our channel and hit the notification bell.